All right, hello everyone. We're looking at lesson 27. We're going to start using the Pythagorean theorem, which is something that should have been introduced in previous math classes, but it's an important part of geometry. So if you have a right triangle, meaning it has a right angle, then what you'll have, the two sides next to the right angle are called legs, and the side across the right angle is called the hypotenuse. So hypotenuse does not necessarily mean it's always the upper right side, and it does not mean that the legs are on the left and on the bottom. It's just the reason that the legs are where they are and the hypotenuse where it is because of where the right angle is. So like when you get here, this is the right angle, so this is the hypotenuse, and these two are the legs. When you go here, this is the legs right here, and then this is the hypotenuse. Using these three things together, you get a formula that works every single time, and it's a squared plus b squared equals c squared. In other words, if you square both legs and add them together, it always equals the hypotenuse squared. All right, so we're going to get into some questions here. Hold on, let me change the view of this. So what I want you to do, I want you to try this. Read this right here, and then try to answer questions 1 through 4. So press pause, read this, and now try to do the 4 questions. Okay, hopefully you've tried them by now. So if you look right here, what you have is it's focusing in. This is a kite. This is to kind of show that this Pythagorean theorem, it's going to work in cases beyond just a standard triangle like this. So in this kite, if you cut it in half, you have 2 right triangles you can use. So in this case, xz right here is what? It is a leg. You see, here's your right angle. So these 2 are your legs. So then xy along here, the spine is what it calls it, is the hypotenuse. And then side zy right here is another leg. What is the length of the spine? So to find the length of the spine, we need to use Pythagorean's theorem. Remember, a squared plus b squared equals c squared. So what will happen, 12 squared plus 35 squared has to equal c squared. So the way you'll do this, it'll basically be 12. Let's see if it'll work okay me doing it this way. 12 squared plus 35 squared equals c squared. So this is what we're looking at right now. So let's solve both of these. So let's do 12 squared. On this little computer calculator I have, I can do this to instantly square it. You might have to put parentheses. You might just do type 12 times 12. But so when we get this, we end up with 144 plus, let's do 35 squared. 35 squared plus 1225, and once again equals c squared. So then let's add 1225 plus 144, and we get 1369 equals c squared. $1369. Okay, so now that we have this, we need to figure out what the square root of this is, because in order to get rid of c squared, you'll do the square root of this to get rid of that. So on your next line, you'll just have c. So basically what you do, you take the square root of both sides. So if you take the square root of the right, now you just have c, but now you have to do the square root of this to get your new answer. So this thing right here will do the square root of what I have right there. See, square root of 1369. You might have something where you take this and then type in 1369, but do the square root of both sides, and now you have 37. So for this, the final answer, when I work it out, is 37. So basically, you just add them, you square them, and then add them, and then do the square root of both sides. So when we do this, we end up with 37. All right. Now we look at this, the spine. Okay, so I want you to press pause, try to do 5 and 6, and then when you're done, press play, and I'll go through it with you. Okay, so you should have tried 5 and 6 by now. If not, press pause and go do them. So AC right here is 28 inches, and then DB is 24 inches. So what you'll want to do if you take AC is 28 inches, cut that in half, and what do you get? You get 14. So that means this right here from A to the middle, A to E, this is 14. And then they tell us that this long one is 24, cut that in half, you get 12. So look, so this triangle is 14 by 12. You see that? 14 by 12. So when they say what is the length of AD, AD right here is the hypotenuse of a 14 and 12 of legs, 14 and 12. You see that? See, this long thing was 28, so half of it is 14. This long thing is 24, so half of it is 12. So it's 14 by 12. So our Pythagorean theorem will say 14 squared plus 12 squared equals c squared. So let's do it just like we did the last problem. So now it's going to be 14 squared plus 12 squared equals c squared. So now let's do 14 squared, and then we're going to do 12 squared. So we get 196 and 144. 196 and 144. And then let's add 196 and 144. So 196 plus 144 equals 340. And then you need to square root both sides. So take this and I do square root of 340 and we get 18.4. 18.4. So 18.4, that's our answer. That's the length of AD. So this length right here is 18.4. So when they ask what is the perimeter of the kite, that means what is the length around the outside. So if this is 18.4, notice if this was 14 and a 12, well then this one right here is going to be 14 by 12. This is 14 and 12. This is 14 and 12. So you would have done the same thing on all the triangles, and you'll get 18.4 for all 4 of these outer sides. So the perimeter means just adding all of those together. So it's just 18.4 plus 18.4 plus 18.4 plus 18.4. Oops, 18.4. So you could have done 18.4 times 4. There's 4 of those sides, and we get 73.6. Okay, now it says how high up a vertical wall will a 24-foot ladder reach if the foot of the ladder is placed 10 feet from the wall. So what this will mean, am I going to need to draw this? So here we go. We can look at this. So here's what they're saying. They're saying that the 24-foot ladder is 10 feet away from the wall. So look what we have. Here's your wall. Here's your ladder. And here's how far away it is from the wall, right? Just imagine a wall right here. So we don't know how high the wall is, so we don't know A, but the ladder is a 24-foot ladder, and it's placed 10 feet away from the wall. So if you drew this yourself, you would draw a right triangle like this, where this hypotenuse is the length of the ladder, okay? So it's a 24-foot ladder, so this length is 24 feet, and it's 10 feet from the wall. So this length right here is 10 feet. And then this right here, A, is the height of the wall. So how high up a vertical wall? So this means since 24 is the hypotenuse, when we do this, it won't be A squared, B squared equals C squared where we don't know C. This time, so if I do this, if it's A squared and B squared, this time A squared is what we don't know. Remember what I was saying? This is your ladder. This is your horizontal length. We don't know the vertical length. And so what we have here, if you set it up, it'll be A squared you don't know. B is the distance on the floor, so 10. And then C is the length of the ladder, so 24. So it actually is going to look like this. Okay, so then when we do this, we do 10 squared is going to make 100. 24 squared. Oh, whoops, I got to reset all this. 24 squared is 576. So then you need to subtract 100 from both sides to get that 100 out of there. So what you'll have then, subtract 100 from here and it's out of there. Subtract 100 from here and it's 476. So now your final answer, do the square root of both sides. And we'll end up having A equals 476. So we can do 476. And we take the square root of 476. And we get 21.8. 21.8. Hold on. That's, yeah, okay, right here. 21.8. Okay. Now look right here, solve for B. Similar situation, except for it doesn't give you a word problem that you have to picture yourself. It's just already drawn for you. So this time the hypotenuse is 38. So let's go here. And the hypotenuse is 38. This time we know A is 27. And this time B is the one that we don't know. So do it like that. So it's 27 squared plus B squared equals C squared. And so let's take this and we'll solve the things that we know. So let's do 27 squared. 27 squared is 729. And then we'll do 38 squared, and it's 1444. And then you need to do minus 729 to get it out of there, and then minus 729. So we'll end up with B squared. So minus 729 gets it out of there, and then we have to do 1444 minus 729. And so we get 715. So now B squared equals 715. And then we have to do square root of the left, square root of the right. So then the square root of 715 is 26.7. And this is all the solve for B. So 26.7, there's our answer. Okay, now I haven't been doing this. I should have been telling you to pause and try it before you see me do it. So pause and go ahead and answer the next two questions and then press play and I'll go over it. Okay, here we get one that's set up like our original questions where x is the hypotenuse now. So you need to find the hypotenuse. So our equation here will be 35 and 14. So 35 squared plus 14 squared is going to equal, I can just do this, is going to equal C squared. So then let's just solve each thing we know. 35 squared, 1225. 14 squared. 14 squared is 196 equals C squared. So then this time there's no subtracting necessary. You just got to add what's on the left. So 1225 plus 196 equals 1421. And then you need to do square root of both sides. So let's find out the square root of 1421. So for me, I can just press this. Square root of it is 37 point, we'll round that to 7. So we get 37.7 for us equals C. So 37.7, there's our answer. Okay. Why does this theorem only work when C is greater than A or B? So I want you to think about what would happen if this length was smaller than this side right here, right? So if one of these was bigger, then when this reaches across, would it reach all the way over to this corner? No, it wouldn't. So the thing, it only works because if C is smaller, then it's not going to complete the triangle. It won't reach the other side. Okay, the last idea here is a Pythagorean triple, which is three numbers that when you take them and you square them, so if you have 3, 4, and 5, that means 3 squared plus 4 squared equals 5 squared. And this is, so 3 squared is 9, 4 squared is 16, add them together, they equal 25, which is 5 squared. So a Pythagorean triple is a set of numbers that work for the Pythagorean theorem, but they're whole numbers. They're not decimals, like a lot of what we've been dealing with. So I want you to try these two, and then, so press pause, try these two, and then press play, and I'll go over them. Okay, is 3, 4, and 6 a Pythagorean triple? Let's go ahead and check. 3 squared is 9. 4 squared is 16. What is 9 plus 16? Well, let's check. 9 plus 16, if you don't feel like doing that in your head, is 25. Is that what 6 squared is? So does 3 squared plus 4 squared equal 6 squared? No, it doesn't, because 3 squared plus 4 squared equals 25. And 6 squared is 36. So no, this squared plus that squared does not equal 36. Okay, that's why. Let's check these. We just tried this, it didn't work. Does 7 squared plus 25 squared equals 26 squared? Well, let's go ahead and check. 7 squared is 49. 25 squared is 629. So add 49 to that, and we get 674. Okay, so this squared plus that squared is 674. Let's see if 26 squared equals the same thing. Nope. Very close, but not quite. We were 674, and now we have 676. Not quite. Let's try this one. 15 squared is 225. 21 squared is 441. Add that to 225. We get 666. That's not a friendly number. So 666 is what we get when you do 25 squared plus 21 squared. And then let's do 25 squared, and we do not get 666. We get 625. So this one does not work. So our last option, let's see if this one's going to work. 9 squared is 81. 40 squared is 1600. Add 81 to that, and you get 1681. Let's see what 41 squared is. 1681. Boom, there's your Pythagorean triple. Okay, so I know I didn't draw this and write it out. I felt like it would actually be easier for you to just see the process the same way every time. If, however, you think you need to see me just draw this like I do for most videos, just send me an email and we can figure something out. Yeah, if you have any other questions, any issues, just email me. And other than that, have a great rest of your day.